normal form means the fourth number of normal form, which is called BCNF, Boyce-Codd normal form. There are scientists or there are inventors who have invented this particular normal form, which is there is a boy and there is a cod. These two scientists, and the initial of these two scientists has given the name, which is BCNF, Boyce-Codd normal form. This normal form is stronger than third NF, and it told us about the determinant. What is the meaning of determinant? Determinant means if I'll write down a functional dependency A determine B, so B is a determinant. Okay. Sorry, A is the determinant. A determines B, so A is the determinant. Determinants refer to the attribute or group of attribute in the left hand side. This is the left hand side. So this is called determinant of the arrow of the functional dependency. Consider a functional dependency. If we are considering the functional dependency like this, employee number is determining some employee email. Here, employee number is determinant of employee mail. Okay? So we know about determinant. Now let's go to BCNF definition. The BCNF, it says that relation is in BCNF if and only if every determinant is a candidate key. It says that in your functional dependency list, every left-hand side part should be the candidate key. So what is BCNF? BCNF says that your relation should be in a first normal form, second normal form, third normal form, and all functional dependencies, all determinant means left hand side attribute should be candidate key. Every left hand side part should be candidate key. If it is not, then there is a problem in BCNF. So we have to split the table. Let R be a relation schema. F is a set of functional dependency over R. Then for every functional dependency, X determine A. In functional dependency F, X should be the candidate key. It says that this should be the candidate key all the time. So let's see with the example that how it works. Now this is the example. It says that this relation is in third normal form. We assume we are having this relation is already in third normal form, but not in Boyce-Codd normal form, which is not in BCNF. Let's see. Let's interpret this. This is A, this is B, this is C. So we have A, B, and C. A, B determine C. Okay, now next is C determine B. Right? This is your functional dependency. Since we have instruction number determine codes number, but instruction number is not a candidate key. So here, let's find out the candidate key. Now, what is candidate key? Let's find out the AB closure. What is AB closure? AB closure will be A and B. A is determining something? No. B is determining something? No. A, B together determining something? Yes, they are determining, which is equal to R. It means that what is the candidate key? AB. Let's find out C closure. Now, what is C closure? C closure will be C. C is determining B. CB is determining anything? Is not equal to R. Means we have AB is the candidate key, and this is also a primary key. Now, if we'll consider AB as the candidate key or the primary key, then this functional dependency is okay because the left-hand side part is the determinant is the candidate key. Now, what about this? Is a candidate key? No, it is not a candidate key. So this is a problem. So what we do? We put we'll put C, B in one table and A, C in another table. Getting it? Why I'm not putting B here? Because if I'll put B, again the same thing will be coming, A, B, C. So A, C in one table and C, B is another table because CB is creating problem. So because this particular functional dependency is CB here, now for this candidate key will be C. So there is no problem. Individually, this R2 is in BCNF as well as here A determines C. Here A is the candidate key. A is the candidate key. So A is individual candidate key, and the left hand side part is the candidate key. And this left hand side part is the candidate key. Right. So now R1 individually and R2 individually are in BCNF, which is Boyce-Codd normal form. So we have this A, C, and B, C, just like this. A, C, and B, C. So A, C, and B, C, we have splitted the whole R relation into two relation, R1 and R2. Now it is in BCNF, Boyce-Codd normal form. So in the